Hi, this is Mike Bixler. I'm going to talk to you a little bit about what we're up to in the computer science class and some of my background. Just to give you some quick background, I did a math undergrad at Stevens, ended up working for a defense contractor for a couple of years. While I was there, they allowed me to get my master's in electrical engineering. Then I actually started teaching, but retained the other job part-time, and they were nice enough to both help me in getting the PhD in computer engineering. And so I still work that other job today at 20 hours a week during the school year, more in the summers, and they always try to get more hours out of me, of course. So I do a lot of the things that we cover in comp sci every day, which I think is definitely a good thing. So as far as what we cover in this course, Chapter 1 starts out with some basics, history of computing, conversions between number systems, hardware and software and components of those, networks and cell phones and CDs and all that stuff and how it works. Just recently, we've gotten into some basic programming within the last couple days. It's definitely sort of a big hurdle, a little intimidating at first. But I think they're doing pretty well so far, actually. We've had some software issues with the computers, but this is normal, so I actually almost embrace that because it kind of shows them what to expect, if they were to pursue a career in something like this. As far as what we use in the course, we use a mix of Java and Python. Java is sort of, a language that's been around for a couple decades. It's great for large types of software. It's what we call object-oriented, which is a good type of language to use for those larger projects. It's also good if they were to do a similar language in their intro comp sci course next year, maybe in college, like C++ or C. They would pick it up very quickly. About, I guess, the holidays, we transitioned to Python, also a very good language, a little more user-friendly. So being that we kind of tackle both, I'm of the mindset, like, get the harder work out of the way first, and so that's where Java comes into play. But like I said, I think it's better to, have this sort of hurdle in a smaller classroom at Mates as opposed to what many encounter where they're in a lecture hall of 200 or 300 students next year at college. As far as lecture style, most of the lectures are based off of PowerPoint slides. Now, I'm not a huge fan of lecturing from slides, so here's my rationale for that. The PowerPoint is just to kind of keep me honest, make sure I'm hitting all the key points. It also allows them to kind of annotate things and take their own notes on different topics. And starting in the end of chapter 1, like we're already there, what we'll often do is go through some conceptual things in PowerPoint, and then we'll transition over to the code and try out some examples. So it's like, here's how this works. Here's a code example, now you go and play around with this. So, again, it's not just 80 minutes of PowerPoints every day because that would drive me crazy as well. So that's the main style until we get to Python, and then it's sort of a little looser. As far as software, we use this development environment called Eclipse for Java, pretty widely used out there in industry. For Python, I'm going to show them a development environment called PyCharm. And there's also this other software called Jupyter Notebook, which is pretty cool because they can, it's almost like a one-stop shop for a presentation. You can put images in there, you can give explanations, you can write code, you can see the outputs of those codes. So for like a final project down the road, they're just going to hand me a single file that has everything in there, and I think that's pretty nice. Some other things we do in class, we do tech articles a couple times a week. I usually find couple of relevant articles relating to technology, not always exactly computer science, but things that relate to it. For example, a SpaceX launch certainly has a lot to do with computers and code and that sort of thing. And we talk about that a couple times a week. I try to get their feedback on things. And that seems kind of a good way to get them engaged to start off class. Days we don't do tech articles, we do other little warm-ups, talking about what we had done yesterday, making sure they don't have any lingering questions, that sort of thing. As far as grading, we do online assessments for almost everything. Most chapter tests have two parts, a conceptual part that's online and self-scoring, and then a coding part where I give them a task to complete once they finish the online part. And they then call me over when the code is complete, and I have a rubric that they're given beforehand to, run their code against to make sure they're handling all the edge cases and things like that. There's a lot of online resources. That's one nice thing about, computer science, that it's so, of course, related related to computers that, you always have the internet available and there's a ton of resources. Some of the ones we're going to use, one is called Codecademy. It's this website where you can run and learn courses and stuff about computer science in various topics right in the browser, so you don't have to install any software. It's usually quite expensive, but they have this educational license where we get it for, instead of $35 per person per month, it's $1 per student per year, and so we were happy to cover that, so I'm not asking for $1. We also use something called CodingBat. That's a pretty cool site written by a professor from Stanford. It was for his intro comp sci class, and what's good about it is it gives you a task to complete in Java or Python, and it then gives you a series of test cases that it will run their code against, and it'll tell you which ones it passed, which ones it failed, if any. And I think that's a great thing because a lot of modern day software fails in ways that a programmer hadn't anticipated. And so it's really awesome when you run some code and you realize that you've forgotten some particular cases. The CodingBat will tell you that, and so you can go and then look at your code and how it could be fixed to address those cases. And again, I think that's really important because that's the bulk of the software crashes and things that you see today because someone didn't think of something. I would say it's quite similar to Rutgers CS 111 when I look at their syllabus versus what we do. A lot of similarities as far as the Java side of things, and so if they were to head there next year, or really any intro comp sci course, I get emails every year, not to toot my horn, but the first couple weeks of school, it's always like, hey, I'm taking comp sci in college, we're using a similar or even a different language, and it's cake. I'm flying through things, I'm pointing out mistakes on the board, so that always makes me feel good. And then, like I said, there's a final project. They'll be given about 2 weeks at the end of the semester, and they're going to come up with a topic they're interested in, find a good data set, propose some research questions, write code to analyze the data, generate some visualizations, explain their conclusions, almost like a chemistry lab, but, relating to computer science and coding. And so they'll do like a quick presentation at the end of that course, but they all seem to enjoy that instead of a formal written final exam. I think that hits the key points. If I can answer any questions for anyone, probably the easiest way is to email me, mbixler@mail.ocvts.org, and thank you for your time.